When we think of planets, we usually imagine relatively young celestial bodies orbiting stars, like Earth orbits the Sun. It's commonly understood that planets form from the leftover material after a star is born, during a period lasting several million years. However, in 2003, astronomers made a groundbreaking discovery. They found a planet estimated to be 12.7 billion years old, nearly as old as the universe itself, which is about 13.8 billion years old. This ancient world is known as PSR B16226b, but more famously, it is called the Methuselah planet, named after the oldest person in the Bible. This discovery radically changed our understanding of planetary formation, cosmic history, and even the potential for ancient life. Let's dive into the incredible story of this primordial world and what it reveals about the early universe. PSR B16226b is an exoplanet, a planet outside our solar system, located in the globular star cluster Messier 4, M4, about 12,400 light-years away in the constellation of Scorpius. What makes this planet especially unusual is that it doesn't orbit a single star, but rather a binary star system consisting of a pulsar and a white dwarf. A pulsar is a rapidly rotating neutron star, the dense remnant of a supernova explosion, which emits beams of electromagnetic radiation at very precise intervals. A white dwarf is the final evolutionary stage of a star that has exhausted its nuclear fuel and collapsed into a dense core. Together, these two remnants form a stellar duo, and around them, at a distance similar to that of Uranus from our Sun, orbits the Methuselah planet. The planet is estimated to be around 2.5 times the mass of Jupiter and, astonishingly, 12.7 billion years old. This makes it more than 8 billion years older than Earth and 2 billion years older than our Sun, providing a rare glimpse into the early era of planetary formation. The Methuselah planet was not found by direct imaging, but rather indirect detection, through its gravitational influence on the timing of the pulsar's radio signals. Pulsars emit highly regular pulses, often compared to cosmic lighthouses. But in the case of PSR B1620-26, astronomers noticed slight irregularities in the pulsar's timing. These deviations suggested that a third unseen object was exerting gravitational influence on the system. Careful analysis and modeling showed that this object was too light to be a star, but had the right mass and characteristics to be a planet. Why is this discovery important? 1. It challenges conventional theories of planet formation. According to traditional models, planets form from protoplanetary disks around young stars, and the process is most efficient in environments rich in heavy elements, such as iron, silicon, and carbon. These elements are created in the cores of massive stars and distributed throughout the universe during supernova explosions. In the early universe, however, such heavy elements were extremely scarce. Most of the matter consisted of hydrogen and helium, the simplest and lightest elements. This scarcity led scientists to believe that planets could not have formed until enough generations of stars had enriched the cosmos with heavier materials. Yet the Methuselah planet exists, and it formed just 1 billion years after the Big Bang. This suggests that planets might form even in metal-poor environments, contradicting previous beliefs. 2. It suggests ancient habitable conditions may have existed. If planets like Methuselah could form early, then the window for potential life in the universe could be far larger than we thought. Life, in theory, could have begun more than 10 billion years ago, long before Earth even existed. This supports ideas such as panspermia, the theory that life might travel between worlds, and encourages the search for ancient biosignatures, perhaps even in unexpected environments like globular clusters or rogue planets. 3. It demonstrates planetary stability in harsh environments. Globular clusters are densely packed with stars. Their gravitational interactions often disrupt planetary systems, making them inhospitable to long-term planetary survival. However, Methuselah has remained stable for billions of years despite being in one of the oldest and most crowded stellar neighborhoods in the galaxy. This raises new questions. Could stable, life-supporting planets exist even in dense star clusters? Could ancient civilizations have arisen long before ours? the strange system of PSR B16226. The binary stars at the heart of this system, a pulsar and a white dwarf, are unusual hosts for a planet. These stars represent the final stages of stellar evolution, and both have undergone cataclysmic changes. The pulsar formed from a supernova explosion, while the white dwarf is the remains of a star that shed its outer layers. The planet orbits this pair at a distance of about 23 astronomical units, AU, roughly the distance from the Sun to Uranus. At this distance, it avoids the intense radiation zones near the pulsar and the collapsed white dwarf. This orbit likely allowed it to survive the violent transformations of its stellar companions. How did Methuselah form? Several theories attempt to explain its origin. 1. Primordial formation. The planet formed around a binary system of two normal stars, which later evolved into the pulsar and white dwarf we see today. This scenario suggests the planet has been part of the system since the beginning. Second, gravitational capture. Given the chaotic environment of a globular cluster, it's possible the planet was captured by the system after wandering through space. Third, post-supernova formation. The planet formed from the debris left by the supernova that created the pulsar. However, this is unlikely due to the lack of sufficient material and harsh conditions. Most evidence supports the first hypothesis. The planet formed early and survived the entire evolutionary journey of its host stars. Could it support life? Given its orbit around a pulsar and white dwarf, conditions on Methuselah are likely hostile to life as we know it. The planet is probably cold, irradiated, and lacks a stable source of heat or light. However, some scientists speculate that if it has a thick atmosphere or subsurface oceans, like Jupiter's moon Europa, then microbial life might survive, protected from external radiation. This is, of course, purely hypothetical, but worth considering in the broader search for life in extreme environments. What does it mean for our understanding of the universe? The Methuselah planet is a cosmic relic, a survivor from an era when galaxies were just beginning to form. Its existence tells us planets may be more common and long-lived than we thought. Planetary systems can withstand stellar cataclysms and gravitational chaos. The timeline for the origin of life might stretch far deeper into cosmic history than previously assumed. This single planet acts like a time capsule, offering a rare chance to peer into a bygone age of the universe, one that predates Earth, the Sun, and even our galaxy's spiral structure. PSR B16226b, the Methuselah planet, is not just an astronomical curiosity. It is a symbol of endurance in a turbulent universe. Despite orbiting dead stars in a dense stellar cluster, under the harshest of conditions, it has persisted for more than 12 billion years. Its discovery reshapes our understanding of when and where planets can form. It opens new avenues in the search for ancient life. And perhaps most profoundly, it reminds us of how vast and mysterious the universe truly is, filled with ancient worlds that have silently orbited their stars since near the dawn of time.